Welcome to our preliminary design review from Team 23088. Our project name is Supplement Recommending Mobile App with handheld measuring device for saliva pH and calcium levels. We're a student startup. We're calling ourselves so far Gesund, and we're sponsored by Dr. Larry Hadd as an experimental entrepreneurial capstone project that they hope to implement more in the future. For our team members, we have Elliot Zerker, who is our team lead. He's also an electrical and computer engineering student who is managing our device that we'll introduce over the course of the presentation. We also have Nathan Herling, who is the procurement lead and also an ECE student. And then we have Keegan Godfrey, who is managing the mobile app and also an ECE student. And we have Annette Garcia, who is our biomedical engineering student and managing the medical algorithm and the medical information that we're extracting from books that we will get introduced as well. Then my name is Raphael. I'm the project advisor, the originator as well. I'm an ECE student, and I'm kind of helping out everywhere that I can with the software mainly and the medical things as well. For our purpose today is that we're here to validate the understanding that we have from the project in addition to the functional requirements and system requirements that our sponsor is expecting from us, in addition to explaining the trade studies that we have done and the point designs and that we've come up with, in addition to showing the models and analysis for that. We also go through the system architecture, block diagrams to show how it all breaks down. We'll go through verification methods, the requirements decomposition. We'll also talk about the minimal viable products that we came up with, making sure that they're in the expectation of the sponsor, and also talk about the risk analysis in regards to those MVPs and our mitigation for those. In addition, we'll talk about our plan, the project plan for our deliverables and the dates to get through. Then at the end, we'll finish with our next steps, the summary, and also the questions that we can look through with the appendix. So for our introduction and to explain who we are, so when we saw that our current medical system is just not performing as it should, we found that a lot of the people in the US are really deficient in their diet, and that the doctors are more treating the ailments and the symptoms instead of the underlying causes. So they're not recommending lifestyle changes and nutritional balance, but rather just treat the diseases. And the purpose then of what we want to bring to the market is to empower the consumer, to make the health come back to them and put it into their own hands so they can take charge of that and heal deficiencies with our services by using our services. And then we'd like to break that down a little bit is that we have a non-invasive biometric device that we're developing, which is for testing saliva values, where if they're high in pH and calcium, then the teeth are very protected from tooth decay and cavities. In addition, we have a blood test analysis in our mobile app that you go to a laboratory, get the values from there, put them into the app, and then based on the algorithm, it will tell you what's going on inside of your body, like how are your organs doing, and then what supplements you need to take to get those back into shape, to cure the deficiencies. And lastly, we have a website with a low barrier to entry questionnaire, meaning that you just answer questions, and based on those, based on symptoms and things that you experience with your body, it will tell you what supplements can help balance those out and make them better. That was the device. So overall, we'll develop a deep understanding of your own nutritional need instead of relying on somebody else. And the startup that we're building around that will provide all these devices that I mentioned. The algorithm will be based on AI, and the device, we hope to expand into non-invasive devices because that's what we think is the future of medicine. In addition to supplement-based recommendations, we also think it's another future of medicine in that it's preventative care. Preventative care is just, instead of just waiting until you have an illness, you catch it way early. And that's both of them will accomplish that, the supplements and the devices. So then to introduce what we've come up with so far, and we'll go through that throughout the presentation and conclude it at the end again, is that for the biometric device, we're thinking to introduce the electrodes into the mouth of the user so that the saliva can be tested during that process, and then displayed on the screen of like, is it in a good range or in a bad range for pH and calcium, so that the user can get immediate feedback, but also that it pairs with the mobile app through Bluetooth, so that the user can have a history of the performance, but also get recommendations to improve the issue in the saliva to get the pH and calcium back up again. And we also can see on the right side an algorithm sample of that we're assigning weights to the supplements depending on what question we're giving. So if the question is positive, then we'll assign the weights to the supplements, but Nathan will go through that later a little bit more. And then lastly, for the mobile app, we have a snippet of the algorithm. Basically, the user values come in and then get tested for different ranges, and if that applies, it will be added to the organ and the consequent supplements.
So now I'm going to be talking about some of our functional requirements and system requirements. So initially, we had 10 functional requirements, which would then use to expand and create our system requirements. So I'm going to be touching on a few of them. So our first functional requirement was that the handheld device should be able to measure pH and calcium in a saliva sample. We then expanded onto accuracy, which says the same thing. It should measure pH and calcium, but it should be accurate to 1 decimal place and in accordance to the standard that it should be biocompatible. It should be a biocompatible medical device. When it comes to interfaces, one of the functional requirements we used was that the handheld device prototype shall be able to calibrate. So the handheld device shall be able to measure and calibration status and display it on an OLED screen in accordance to another standard that it should convey safe and effective use for medical devices. Another functional requirement is number 9, and that's that the website and app should keep track of the user's accounts. So we obviously wanted to store data, but we also wanted to be secure, which is why we have system requirement 4.32 data control, that access to the Firebase user storage shall be strictly controlled by custom and security rules. When it comes to efficiency, we want the handheld device to be reusable, and for the system requirement, we stated that it should be reusable for at least 30 times. For performance of our app, we want it to recommend supplements and alleviate organ deficiencies. So this correlates to the app's AI algorithm, which should connect an organ to the deficiency, and based on that, it should recommend the following supplements. When it comes to design features, we had a few which relate to weight, size, and packaging, but there are no functional requirements directly related to these.
All right, so I'd like to take us now into our trade studies, point design models, and analysis. So as Raphael mentioned at the beginning of this presentation, our system really actually kind of has 3 systems to it. 2 of those are largely software, so we weren't able to do a real trade study on those systems, so instead we chose to focus on the handheld device. So I'm going to walk through you right now what our trade studies were for that particular device, and we'll arrive at our point design by the end of it. So our 3 trade studies that we got here, our first one was kind of the most intuitive. The user places the device in mouth, very similar to existing technology out there, kind of like the thermometer that we're all accustomed to for taking our temperature when we have a fever. The next design that we had, it features a built-in receptacle into the device that the user would spit into to cover the electrodes in saliva and get the reading that way. This is actually very kind of based off an existing product that we found out there that's made more for a laboratory setting, but we kind of like the idea and we thought it might be applicable for our design. And finally, for a third trade idea, we have that the user spits into an external receptacle that gets plugged on top of the device. This is kind of our own brainchild, as it were. It works exactly the same way as the second design, except that now the receptacle is a little more difficult to get on top of the device. So we decided that we needed to do a little bit of analysis to arrive at our final decision here. So we came up with a decision matrix listing our trade factors here. So first of all, we have performance. Performance is weighted very high at 8 because being a biomedical device, integrity is one of the highest, most important things we need for a functional medical device to pass medical standards. So that's why we assigned it a fairly high weight of 8. We also, along with it, we assigned schedule a pretty high weight because being a student startup, it's very important that we have a functional product by the time we're done with this device. It really wouldn't be any good for us to have a non-functional device by design day. So it's very important to us that we have that done. We also stuck usability is at number 6, which is a little bit less, but also fairly high. We want this to be an intuitive device that consumers can easily pick up on and start using. We don't want to drive away potential customers just because our product is clumsy and difficult to work with. And finally, our last trait factor is cost, which we actually put pretty low simply because it turns out that all of our trait designs are going to actually end up costing pretty much the same because as you will see when we do our budget analysis, the most expensive part of this project turned out to be the electrodes, and all 3 designs require the electrodes, so there's no way to really get around that, so cost was less important to us. So based on that decision matrix, I'll go back really quick, and you can see our highest scoring point design was in fact the place and mount design at 196.2. And so based on our decision matrix, we arrived at that point design. And although we projected there's potential for less accuracy than the other designs were involving the user spitting into a receptacle, it excelled in terms of usability and schedule, which is why we ended up choosing it as our point design. The internal receptacle primarily fails in terms of usability. We didn't want the user to have like a learning curve. Plus also it's a little bit revolting in use to spit into a device and play with it that way. It's kind of gross and unhygienic too. And finally, the external receptacle was honestly just another version of that, but even more complicated. And we don't have a mechanical engineer on our team, and we realized that trying to have a piece that would plug onto it is a mechanical problem that we would not be prepared to address. So some models and analysis that we can apply to this system. Ultimately, this device will rely on a simple linear relationship, y equals mx plus b, for pH and calcium. All the ISEs rely on this linear relationship, which we will have to calibrate and find for ourselves. Another set of important relationships that we're going to keep track of here are specifically that between bit resolution and digital resolution. The ISEs are outputting an analog signal, and we're going to be processing a digital signal. Higher resolution higher resolution will give us greater precision and the accuracy that we need, but it also drives us down to a smaller noise floor, and hence our system would become less immune to noise. So we're going to have to pay attention to these relationships when we're finding out the trade-off between those two. And just a couple of other models worth mentioning really quickly here. Power consumption, I'll talk a little bit more about that later. And finally, component geometry. We have, from our system requirements, we have some spatial requirements for our system, so we just have to make sure that none of our components that we end up purchasing exceed those conditions. And pictured here, for example, is the OLED display. We're going to have to make sure we pick one that's small enough to fit inside our thermometer or our handheld device.
Let's talk about system architecture and system block diagram. So, as has been mentioned, our system consists of really 3 subsystems, each of which itself could be considered a system on its own. That would be the handheld device, which is an embedded system, the application or the phone app, and the website. Here's a little more detail of one of the subsystems, which is the website. We have some nomenclature on the right, component, subsystem component. The website itself consists of what we can call 4 subsystems, and each has a functionality necessary for the entire component, which is the website.
And then for the system block diagram, which is also a flow-down diagram, for the higher level interfaces that you can see on the top right side, there's a user control and action or interaction between the user and our devices, where straight going down, it will be into the main page of the website, and then going into the left area, which is the handheld device, they can interact with the buttons and the LCD screen there. And then on the left side, you can also see that saliva is interacting with the electrodes, being the calcium, the pH, and the reference electrode. And then a little bit further down, you can see more user interaction between the mobile app that is interacting with the phone screen. So again, device at the top, mobile app on the bottom, and website on the right side. There's also digital communication in between the components of the device at the top, and analog communication as well. And with the website on the right, there are more hyperlinks that are interacting between the different screens. Then zooming a little bit into the app, mobile application flow diagram, you can see that at the top there's also Bluetooth interaction between the device itself and the handheld device and the app, so that the user can access the values that are being measured. In addition, there's the app delegate, which is the kind of brain of the application, which determines which screen gets opened first when the user opens the application. In addition, when you look further down, it says enter blood values VC, which is the view controller, and there's 3 ways the user can actually enter those values. And then, in addition to just entering them manually, we will also have a computer vision feature and algorithm that will populate those values automatically, so the user doesn't have to enter 56 different values. Lastly, there's also a page on the portal that we want to implement so that the user can access similar request or a similar portal and just download the values directly from there. Yes.
Okay, up next is our system requirements verification methods and our requirement decomposition. So here's a look at our SRVM matrix. Here's another look at all of our system requirements that Annette touched on a little bit before. As you can see, we have our tests, analysis, demonstration, inspection, verification methods. These are how we're verifying all of our requirements. So up next, I've pulled out 3 of the requirements, and I'm going to talk a little bit more about those in depth. So first off, we have 4.5.2, identification, which requires that the mobile app's AI algorithm will be able to identify which organs are nutrient deficient based on given blood test values. Next up is 4.5.3, correlation, which requires that the mobile app's AI algorithm will be able to connect organ deficiencies to recommend supplements for the user. Then next we have 4.5.6, the website AI, which requires that the website will use AI to ask the user a series of questions that will lead to a custom set of supplement recommendations. So the reason I pulled out these 3 is because they're really the core requirements of the software aspect of our project. Identification and correlation pretty much define the entire functionality of the algorithm, which is essentially what our MVP is for the application. Same with the website AI, that's the main functionality of the website. These will be verified for identification and correlation through a test. We're going to run through our algorithm with previously known blood values to compare what the output should be. For our website AI, that will be verified through a demonstration, and we're basically going to run through the questionnaire to make sure that our inputs match our outputs. Okay, up next, we have some verification methods that I pulled out. So first up is 5.3.2 data control. So what this system requirement is it's basically that the Firebase needs to be strictly controlled with access rules so that only users are seeing what they're supposed to be seeing. So the verification method for this requirement is that a demonstration of database read and write access rules will be performed using users with varying levels of database authority. So these 3 types of users that we're going to be demonstrating with are an administrator, an unauthenticated user, and an authenticated user. So administrators are would be one of us. We're able to access and overwrite all non-sensitive information. And I say non-sensitive because since we are a startup, this is going to be available to the public. We're dealing with certain sensitive health information, so we're going to use end-to-end encryption so that we aren't able to access any personal information that we shouldn't have. Second, our unauthenticated users will not be able to access any part of the database because they really have no need to. And third, our authenticated users will only be able to read and overwrite data within their own user bucket. So essentially the way our database is set up is we have a list of users and their user IDs. As soon as you're authenticated, you're given a user ID that matches to your device. You're only able to access data within that specific bucket in the database. So that just makes sure is that if I were to use the app, there's no possible way that Raphael's data would come into my application.
Okay, so now we're going to dig a little bit into the decomposition of our system requirements. So at the end of this slide deck, we have an appendix where we've broken down every single system requirement to the subsystem level. But I want to bring out just a couple here that are very interesting and very relevant moving forward with our very earliest minimum viable product. First of all, one of the ones I'm most interested in is handheld device accuracy. So this particular requirement is going to be verified at the system level, but it is derived to certain subsystems, for example, the ISE sensor system. This is where, as mentioned before, we have this analog to digital conversion process going on. So we're going to have to be very conscious about the values we choose for the bit resolution because, as mentioned before, high resolution is necessary to achieve the desired accuracy, but it also drives us closer to a smaller noise floor, so might start seeing noise in our system. So this is definitely a requirement that we're going to want to dig into and start experimenting with as we do MVP1. Another one that's very interesting to me is the power for our system. This is going to get, this particular requirement is going to be allocated across all the subsystems in the handheld device because every subsystem is either drawing power or providing the power. For us, to make this a viable consumer product, it's very important that it can be a low power system with a long shelf life. You don't want to go to your shelf, you don't want to go to your cabinet and take out your thermometer and it's not working because you need to replace its battery. Similarly, for us, we want to make sure that our handheld device is going to be working whenever the user wants to use it. So that's why power for us, making it a low power system is very important. This includes things like we'll have to consider the voltage regulator that we used for our power supply is going to have to be very efficient. Things like that we're going to be paying attention to very closely.
Okay, so our requirement decomposition for the mobile app, we're going to look at correlation, which, like I said, is the algorithm connecting deficiencies in certain organs and recommending the user supplements to take so that hopefully they improve a little bit. So this flows down to our graphical user interface, which essentially just means that the supplement page has to be displayed to the user, or else there's no algorithm, nothing would really work. And then our other subsystem for our algorithm, it's just derived straight from the requirement. It has to be able to connect organs and their deficiencies to recommend supplements. And these are going to be verified through, like I said, a test of blood values that we already know. Yeah.
Continuing with the requirement decomposition, examining the website. So our document is 4.5.6. The website AI is what we're going to look at here. And it shall ask user a series of questions, and it's going to lead to a custom set of supplement recommendations. So this requirement flows down directly from the system requirement, as discussed before. And the verification for this requirement shall be through demonstration of known questionnaire responses to known supplement recommendations. And this is the most important component of our website, as it is essential to the functionality of recommending our supplements, which is what we're trying to accomplish.
So now that we've introduced you to our system, point design, our system requirements, we'd like to dig a little more now into our minimum viable product. We've already mentioned it a couple of times, but we're going to formally introduce it here and define it. We talk about the models, the analysis, and what our verification plan is when we develop our minimum viable product. So for the handheld device, for the MVP1 for the handheld device, we're going to be just using a breadboard setup to verify the conceptual layout that you see there on the right. It will be able to do the following. It will be able to read pH and calcium values from the ion selective electrodes and print them to the serial monitor. It will be able to send Bluetooth data across a connection to a host device. It will be able to print characters to an OLED display and log button presses on the serial monitor. So I've chosen this particular design for MVP1 because I believe it verifies the most critical elements of our design, which are in fact reading pH and calcium concentrations from the ion selective electrodes. This is because the sensors are really the only unique aspect of our embedded system. Everything else is user I/O and program control. These problems have been solved over and over again for every single system. I have no concerns about being able to implement all that. But the theory behind ISEs is sound, but the technology is new to us. So this is why I consider it our most critical element. In addition, we have Bluetooth in embedded systems is new to us working on this project. Therefore, even though it's a common technology, but since we haven't worked with it before in embedded systems, we consider it a critical element to get it running. And finally, the remaining critical elements, the user I/O, they don't pose any technical challenge, but they are necessary to have a product that a user can actually use. So that's why we include it in MVP1. And kind of continuing on this theme about our need for accuracy with this device, we've come up with some experiments and some tests to verify this. So since we identified that this particular requirement will be verified through test and analysis, so I've come up with an experiment that we will use to collect data and verify the accuracy of the ion selective electrodes and establish that linear relationship that I mentioned earlier between the voltage between voltage and ion concentration. And all the experimentation that will be done in the experiment I'm about to describe will be taking place in an electronics lab, namely the IEEE lab room here on campus. So what you're going to need, what we will be needing for this experiment, we're going to have a PC running the Arduino IDE and the Microsoft Excel, a USB cable to hook up our breadboard setup of our minimum viable product 1. We will have calcium standards and pH buffers for calibration. These are actually being provided. We are actually buying from the same vendors who are providing the ion selective electrodes. And finally, some pure water, as well as gloves and eye protection. So, as a safety precaution, we will be wearing gloves and eye protection while conducting these experiments because we will be working with said chemicals, pH buffers. The required software, the Arduino IDE, that's going to be needed for reading and printing the values that we're getting from the ion selective electrodes. And Microsoft Excel is our tool of choice for performing the analysis on the data that we collect.
Okay, so now I'm going to talk a little bit about our MVP for the mobile app. So the MVP for the mobile app will entirely focus on the algorithm, which comprises sort of the core functionality of the app. If you see to the right here, we have a little glimpse of it. The user's blood values come in, they're going through all of these checks, and we're going to get those outputs to the right. So the MVP will do 3 things. First, it'll receive the user's blood values. Second, it'll associate these blood values to corresponding organs, whether or not they're deficient or if they're perfectly healthy. And then third, it will recommend the user supplements to the associated deficiencies within their organs to hopefully improve their health a little bit. For example, it might be a little hard to read, but if I were to have high LDL, low HDL, and high glucose, the algorithm would detect that there's probably some sort of deficiency within my heart and blood vessels, and I'll be recommended to take kelp, phosphorus, potassium, vitamin A, and vitamin B complex. Okay, so our mobile app critical elements. So the system requirements that the application will verify are mobile app accuracy, which requires that the app shall be able to receive the blood test values and do operations on them with an accuracy of up to 2 decimal points. Identification, which requires that the algorithm shall be able to associate deficiencies within organs based on inputted blood values. And then correlation, which will get recommended supplements from these organ deficiencies. So this is really what makes our app unique. Any other components that make up the mobile app UI are really well established. They've been done millions of times. So if the algorithm isn't functioning to a satisfactory level, then the completion of our app really has no purpose within our project, which is why this is what our MVP is. Okay, so our acceptance test for the MVP, we're going to be testing the algorithm accuracy, verifying identification and correlation requirements. So the hardware needed is basically just an iPhone running iOS 13 or higher to run these tests. The algorithm will be tested with a set of known blood values and known outputs to ensure that the correlation and identification requirements are met. So here's an example below of something that our test engineer would receive. So he would go into the app, go to the enter values page, enter these required values, and just ensure that they match the outputs that are given to them as well.
So if we recall, our system is really 3 subsystems, and this is the 3rd subsystem for the MVP. So this is the website. So on the top block here, we have the MVP website shall meet the following criteria, and on the bottom we have it shall do the following. So back up to the criteria, we want low barrier to entry points all over the place, because we want to make it easy for people to get access to this. So the first point would be to serve the low barrier to entry points to the product suite, mobile app, and handheld device. And the second would be to consist of a questionnaire, which provides another low barrier to entry engagement for the user and sponsors line of products and services. On the bottom of the slide, we're doing what the website shall do. Well, it shall provide help questions, and it shall provide supplement recommendations based on the results, and it shall direct customers to product purchases through e-commerce platforms. Here's an example of our website critical element. So this top, it's called a table. On the top row, we have questions, and then on the left column, we have supplements. and we're assigning scores, sort of an XY scheme there between supplement and question. This will be a collection of data which we're going to process and some machine learning algorithms. But at the moment, on the bottom, I included a pie chart just to make it look like this is a supplement percentage. So we can take supplement percentage directly and just try to map it to e-commerce websites or recommendations. This is what an acceptance test is. So we're working with a website. So the first thing to do would be to go to a website. The second thing would be to fill out predetermined answers to the questions that appear on the website. And of course, that would help to match up with predetermined results. And then you would just record a pass-fail. When's it due? Well, it's due December 1st.
So now I'll be talking about risk analysis, project plan, deliverables, status, and budget analysis. Beginning with the risks, we have identified 5 risks, and we assigned different risk scores based on the risk cube provided at the top. So our first risk is that we don't have a mechanical engineer in the team. So the way we did this is it would have moderate consequences, but we're 100% certain that we don't have one. Therefore, this would be a risk score of 15 with likelihood being 5 and consequence being 3. For our risk number 2, our device sensors might not work with saliva. So this would be a major consequence, but it's a moderate likelihood, which gives us a risk score of 12. Our third and fourth risk have the same score, being 8, because they both have major consequences, but they are pretty unlikely. And that's the links between blood values and illnesses for the app might be incorrect, or the links between the illness organ and supplements for app might be misunderstood. Our last risk is the value association in machine learning algorithm for website might be off, and that is also a moderate consequence and a moderate likelihood, which gives us a score of 9. Therefore, we have these arrows pointing towards where we want to get these risks, where they're in the moderate or low range. So here are our mitigation plans for some of the risks. So for the first risk being no mechanical engineer, our first mitigation plan would be to learn skills that are missing or apply skills that we already have, such as 3D printing, SolidWorks. But this still leaves us at some risks. Therefore, Dr. Head said we could procure a junior mechanical engineer in case that we needed more guidance in these subjects. Our risk number 2 is the device sensors might not work with saliva. So we will be performing a voltage and ion concentration in sufficiency large saliva sample. And in case this is successful, we will prototype with the current point design. But in case it's not successful, we will change the prototype to a different point design and perform a prototype test. For risk 3, the links between the blood values and illnesses for the app might be incorrect. So we want to prototype the test, so we want to verify against the book values, and we also want to make sure we have correct implementation. This would reduce the risk, but we additionally want to consult an expert because by no means are we medical experts, and therefore we want to make sure our product is safe and viable for the consumer. So now I'm going to be touching on our project plan. So here we have a Gantt chart of the deliverables for the website in green, the device in orange, and application in blue. And we also have some of the major milestones highlighted along with an X to when they are due so that we know we're on track for everything. So some of the deliverables would be such as extracting medical values for the application or creating a skeleton for the website, ordering sensors for the device, etc. One of the critical paths we did identify is for one of the sensors we ordered, NT sensors. We had troubles contacting them, and they're also shipping from Spain. Therefore, if this delays more, we will be delayed on when we want to prototype this sensor. So now, leading up to the CDR, we want to start and finish the algorithm prototype for the application, as well as implement computer vision for entering blood values for the application. We also want to develop the questionnaire prototype for the website and the sensor prototype for the medical device, as well as test sensors and reporting for the medical device. and this is leading up to November 29th. Along with this, we also want to verify correct implementation by comparing prototype results and book values, and also consult the medical expert to confirm validity for these values. So some big project deliverables and deliverable dates are the video presentation, which is due April 18th, 2023. The mobile app, website, handheld device, and handheld device user manual and final report are all due on May 2nd of 2023, so it's something to keep in mind. So currently our project status for each of our subsystems, starting with the device, is that we have ordered parts for a prototype and we have the diagrams mostly all completed. For the app, we have added Firebase for user account, backend API, and we have developed the medical algorithm for the prototype. For the website, we built the first skeleton of website interface, and we're currently researching ways to implement the questionnaire and machine learning algorithm, which means we're on track on our deliverables. So now we want to mention some of the materials that our sponsor provided, and that's the mobile app skeleton. So he had a pretty good basis that we can see on the left of the app, as well as medical books for blood chemistry and application of nutritional supplements. And he was also nice enough to provide snacks at every Friday meeting.
Yeah.
As the procurement lead, here's some budget analysis. So over total $4,000 budget, we currently have about $1,800 allotted. If we look on the left column, there's verbal descriptions of what's going on there. And as Elliot mentioned previously, pH electrode is the first electrode mentioned there. So all our electrodes are the most expensive components, and they're also the hardest to get hold of. So at the moment, we still have about $2 grand left in the bank. So without any reference point, I feel we're doing good.
Right, now to one of the last steps and slides that we will go through. We'll go through the next steps for our project, the summary, and then lastly end with the questions. For the next steps, as Ned mentioned, we have currently developed the parts that we will need for the prototype. So a lot of the components are already there, or we've been able to research. We've ordered parts for the device that are coming in. We've researched the algorithm that we're building for the app, and we have the questionnaire building for the website. In addition, we're also building the MVPs on the side. We will also work on mitigating the risk. We're contacting experts through the McGuire Center for Entrepreneurship New Venture Development program. We have a grant there with them that we can use to apply for experts and anything that can help us for the startup. And we will also make sure that we prepare for the critical design review that is coming up very soon. Then to recap and summarize what we've said. So we have the three components that we've gone through: the device, the mobile app, and the website. For the device, we've been thinking that the point design where you insert the device into your mouth is the most natural, instinctive maybe that you can perform with such a device to do the measurement for the saliva. In addition, for the app, we're prototyping the algorithm and making sure we have expert advice to verify those results. And same for the questionnaire with the prototype for the website. And we will also demonstrate that the machine learning algorithm works as we intend, because we will have a little bit of a combination where we will hard program some of the questions and answers to result in different values for the supplements, but additionally implement the machine algorithm. So we'll have to see how that balances out. So it's a little bit of the purpose for the prototype, to see how that works. And then lastly, for the questions, we're opening the floor for the questions that you might have. We're interested in seeing what you have for us as feedback, because we need to validate our understanding and the prototypes. Thank you very much.
Sorry, just a couple of questions.
Yes, please.
You mentioned something about unauthorized users or unauthenticated users. What are those exactly?
So essentially we're using this thing called Firebase a user can log in, and so their health values can be stored in a database so that they can see an entire history of their results that they've been entering. And you have to be authenticated to gain access to this database. So essentially, like, my specific device, when I would log in with my account, which would just be like an email and password, it would connect me to Firebase, and I would have strict access just to my personal information. So we're doing that just so that the data isn't stored locally. So like if I were to get a new phone, my information would still all be there. If I were to accidentally delete the app or iOS were to uninstall it for whatever reason, I could just sign back in and all my information would be there. And an unauthenticated user could theoretically still use the app. They just wouldn't be able to save their history. They could still do like a one-time test or anything like that, but yeah.
Okay, maybe also add to that, because we were looking into the HIPAA compliance. As far as we understand, we are not falling underneath that those rule sets because the users are they're volunteering the information to us instead of us working with a medical professional who diagnoses them and then saves those values for them. So we don't fall under that. Additionally, but we do want encryption, we do want safety for the user so that we can advertise it that way, because we want to gain the trust of the user instead of just using the data like other big corporations do.
So my next question is, you talked about the AI looking at all the data that they had coming in and then deciding what to do in terms of what supplements to recommend. How are you getting that information? Where's it coming from? Is that your medical expert? Are you guys figuring out what supplements will help with whatever?
Yes, so our best guess of, so how we're starting, and this is definitely one of the big points for us. We're starting with the book. So this book here, for example, the blood chemistry, the CBC analysis, it's a whole branch of the medical world. It's called functional blood chemistry analysis. It's not in the mainstream science as much, but it definitely is well understood and appreciated by the patient. And what it does is it looks at the ranges of the blood values that are coming in from the user. So basically, as I mentioned, they go to a lab, get the blood test done, the values they bring to the app, and then the app has different ranges that they fall into. So when they're in the core, in the center, in the middle, that's a very good optimal range. But if they fall a bit outside, it's suboptimal. And when they even fall further, it's very critical and alarming. But the usual ranges that you see on these blood tests are just the critical ones. So the doctors have found more optimal values in the middle that you want to fall into. So we have several books that we're working with, about 4 books actually, and they all have similar topics of supplement recommendations, applied supplements, applied nutrition, and these functional blood chemistry analysis. So that's what we're using so far, but again, we don't want to rely on that because in case we misunderstand or in case we make mistakes, it can be dangerous. Hopefully it's not as much because it's supplements, so the worst case usually with supplements is that you get digestive issues instead of severe side effects. So that's what we're hoping to have a little bit of a buffer there, but again, the experts will help.
So are you asking the user questions like what kind of medications are you taking right now so you can check side effects and interactions?
That's a very good point, because I found, for example, that if you take blood pressure medications and additionally take magnesium, the body will lower your blood pressure because it has no magnesium, but then you take medication that will drop it additionally. So if it's like 30 or 40 points for the medication plus the magnesium has like 30, it's like a severe drop in blood pressure that can end up actually being fatal. So that's something we need to be aware of. What we've thought about is that we may block users that have a lot of issues that we detect, like a lot of different organs that are in trouble, and maybe implement a database of local naturopaths or physicians at least that they can go to that we can refer them to. So have like a partnership with those as well.
Does anybody have experience working with AI?
A little bit.
So,
It's a good challenge for us.
so what do you expect the issues will be in implementing the AI?
Yes.
How's it going to go?
Can I give that to you for the other? So we were looking at the books, extracting how the blood values point towards different illnesses. So when you can see the if statement, that's basically the algorithm. And I think AI is a little bit overhyped, to be honest. It's basically just script saying like, if you have if statements, if this happens, then this. It's like AI, artificial intelligence making decisions. And just like what we are hoping is to kind of replace a homeopath, a naturopath, I mean, over time, like a physician to a degree. So as you can see, the first statement says TSH above 4.4, T4 above, or actually below 6, T3 below 100, cholesterol above 220, and triglycerides above 110 will indicate that you have an issue with the thyroid. I think it's here actually hypothyroidism, which is the underperformance of the thyroid. And then to cope with that and to balance it out, the book that we have recommends kelp for the iodine, L-tyrosine, which is an amino acid, vitamin B complex, which is like B1, B6, B12, B2, I think as well.
So this set of kind of if statements all came from the book?
Yes and no. So one of the books looks at the blood values and says which illnesses come from these blood ranges, these indicators in the blood, the different values that point towards illness. The next book then says, based on illnesses, these are the supplements that you want to take. So we've been stitching these together, a little bit hopeful, but so this is where we came up with the algorithm, hoping that it will perform. But we need to double check that for sure.
We should probably more triple check.
Yeah, I agree.
So one of my concerns would be is if you have questionnaires that you have put together that people will give you invalid or wrong information,
Yes.
which then causes all kinds of issues. Obviously, how are you going to avoid that?
Yes, so there are already companies out there that do have questionnaires like that, where they ask you, are you spending a lot of time sitting? Are you spending a lot of time inside? Do you have migraine? Do you have, are you able to go outside? They compare these and then recommend vitamin D to replicate the sun exposure, or ashwagandha, I think, for migraine, things like that. So usually, so that's already established to a degree. That being said, supplements don't have a big impact on you. It's not like certain medication that really has big and severe side effects. So even if they put in wrong information and get supplements that don't necessarily help them, it usually shouldn't have any effect on them. Either has no effect, or it helps them, or worst case, if they really overdose, might have diarrhea.
Yeah, it actually gets a little bit more complicated. I'm actually heavily into supplements.
Oh, very interesting.
I can tell you.
Okay.
So do you have, when you're looking at making recommendations, you also ask for existing medicine they're taking? Are you asking them for existing supplements they're already taking as well and taking those in consideration in your recommendation? Or are you just going to recommend stop what you're doing right now and replace it with this?
Right, so to be honest, we haven't come that far yet. We're trying to build it from the ground up, having prototypes that work, have a level of ability to work at the beginning. But also I think what we're targeting and working with that on the business team is to target athletes probably, instead of really sick people. So maybe it's then to brand ourselves as a preventative company instead of a really curing company. I think the potential is there for supplements, but it's probably just very difficult for us to attain that. Rather, preventative care, catch deficiencies early on, like a calcium deficiency, just go into that, or B vitamin deficiency. So I don't think we should get ourselves into the critical area of helping people cure illnesses, probably. Over time though.
Yeah. A couple of other concerns I have. This is a very large project.
Yeah.
With a lot of moving parts, broken into several sub-projects, which is real life. But are you aware that the scope creep and the potential problems could really push you off at the end? What are you doing to avoid that?
Definitely. So we're focusing on these three elements: the app, the website, and the handheld device. For the handheld device, actually, for the initial description and the problem statement, I asked for just a prototype. So get it to work, get the sensors to work, have an interaction with the saliva, proof of concept. For the website, have it working, have it running, and then I can take that after the senior design, talk to more expert, expand it, and mostly also for talking to investors, like getting the idea out there, getting some funding, getting some interaction, I guess. Scope creep, yes, but we try to focus on prototypes and proof of concepts to expand over time.
May I make a suggestion that you may rename AI? Because AI talks about machine learning.
Okay.
Your system doesn't do machine learning. It does more system analysis, and then based upon that, it brings a result. Otherwise, you might get people the wrong
That's fair.
impression.
Okay. That's fair.
team of any kind?
We do through the McGuire Center, and I keep pointing that direction because it's our business team back there. And we have Ceci on the right and no on the left.
There will
It's
be
gone.
legal issues involved.
Yeah, legal team definitely, it's very dangerous to just recommend things to people and telling them it will help them, so we have to be careful that way. User agreement at the beginning, explaining them, don't take these things so serious, like it's not FDA approved, and like what you have in supplements usually.
Do any of the teams have questions for Lucy? This is your chance.
I noticed you mentioned a specific battery. I believe it was like the CR1225. Is there a specific reason you chose that battery over others?
Oh, you're talking about the coin battery probably on.
Yeah.
So I chose that one because it's a 3-volt battery right now, and that's what we're shooting for right now. I just really wanted an image of, give you an idea of what we're looking at. It may not necessarily be exactly that battery, but it's going to be a 3-volt system.
Anybody else? Otherwise we're good.